Welcome Calculus AB. This is 1-3, Evaluating Limits Analytically. The essential question is, what is the difference between evaluating limits analytically and graphically? Let's begin. So we don't need a graph to evaluate a limit. We can evaluate it with an expression. So we have three different examples here. So b and c are real numbers, and if the limit of b is x approaches c, it's going to be b. So limit of 3 as x approaches 2, well, it's 3, because it's always going to be 3. X doesn't change it. And limit of x as x approaches c is c. It's just plugging it in. So limit of x as x approaches -4 is -4. And the last one, limit of x of sub x to the n power as x approaches c is c to the n power. You plug it in. So limit of x squared as x goes to 4 becomes 4 squared, which is going to be 16. Now, we have a bunch of properties of limits here. And these are similar properties you've seen with variables before. Scalar means you can multiply by some number. Sum or difference is if you have two functions, limit of two functions, you're adding them or subtracting them, the limits can be separated. So limit of L plus K. And if you multiply the functions together, it's the limits multiplied together. And if you divide the functions, then it's the limits divided. And if you take a function to a power, then it's the limit to the power. So let's do some examples of that. So if I wanted to find the limit of 4x squared plus 3 as x approaches 2, okay, I can just plug in 2. And it becomes 4 times 2 squared plus 3, which is going to be 4 times 4 plus 3, which is 16 plus 3, which is 19. Now, another way I could do this is by breaking this up. So it's like the limit as x approaches 2 of 4x squared, and the limit, and a plus the limit as x approaches 2 of 3. So on the left-hand one, you plug in 2 for 4x squared, and you get 4 times 2 squared, which is going to be 4 times 4 is 16. And limit of 3 as x approaches 2, well, it's just going to be 3. 16 plus 3 is still 19, so you could break it up. Rational functions. So if you have a polynomial function, basically this means that if we can write these as a rational expression and find the limits, and that still works. So example, right here, the limit of x squared plus x plus 2 over x plus 1 as x goes to 1. Let's just evaluate that. So it becomes 1 squared plus 1 plus 2 over 1 plus 1. So what you're going to get is 1 plus 1 plus 2, so 4 over 2, which is just 2 for your answer. Now radicals, you can also use radical limits. So if n's a positive integer and you have a positive radical, so the limit of radical x to the nth root as x approaches c is just plug that c in. Alright, so for this example here, as x goes to 0, I'm going to plug in 0 for x squared and write the square root of 0 squared plus 4, which is going to be square root of 4, which is just 2. Now, a composite function. So we can use composite functions for limit as well. So what this is saying is you got limit of f of g of x, so g of x is inside of f of x. We can instead write that as f of the limit of g of x. We can put that the function f on the outside, and it'll still work. So one way to think about this is go back to that last problem. This can be a composite function. And I can rewrite this as, take that square root function, basically take it to the outside. The square root of the limit as x approaches 0 of x squared plus 4. So you evaluate inside that square root. And I can say the limit is, just plugging that in, that becomes 0 squared plus 4, so 4. And it becomes the square root of 4, which is just 2. So it's just another way of writing that. You can take the outside, that square root function, but either way, whatever. All right, trig functions. Hey, they work the same way. You just plug, as you're approaching c, just plug that in for the sine, cosine, tangent, cotangent, secant, and cosecant. So the limit of tangent of x as x approaches 0 is just going to be tangent of 0, which is going to be y over x, 0. All right, the limit as x approaches pi of x cosine of x is going to be pi times cosine of pi, and cosine of pi is the x value, so that's going to be -1, so pi times -1, which will be negative pi. And the last one, limit of sine squared of x as x approaches 0 is going to be sine squared of 0, and sine at 0 is your y value, since that's going to be 0 squared, which is going to be 0. Yeah, 0. My picture's covering it up. All right. So those are examples that can be solved with direct substitution, but what about when it doesn't work? So what we can do is, what this says here, c is a little real number. Basically, so if f of x equals g of x, except for there's certain values for x, so x can equal c, where that just doesn't work because we have an open spot on the graph. If the limit of g of x as x approaches c exists, then the limit of f of x exists. Think whatever this says here, think factoring rational expressions. And so let's do an example to explain this. Wrong way. So I want to find the limit of this example. And if you, like last ones, if you tried plugging this in, you would get 1 cubed minus 1 over 1 minus 1, which would be 0 over 0, and that doesn't work. So we have to try a different way of doing this. So what I'm going to do first instead is I'm going to factor. And this, maybe hopefully you recognize this as the difference of cubes. And I wrote the formula right here just to remind you, because you probably don't remember. So I'm going to rewrite that as limit as x approaches 1 of, and so AB. So in this case, my A is going to be x and my B would be 1. So it'd be x minus 1 times x squared plus 1 times x, or x plus 1 squared, which is 1, all over x minus 1. And what cancels out here? These x minus 1s. So what you have here is a limit of, as x approaches 1, of x squared plus x plus 1. This is going to be the same as the original. I plug that in. That becomes 1 plus 1 plus 1, which is 3. So the limit of this original function up here is just 3. All right, moving on. So here's some general strategies, like you don't know how do I get this to work. First, try direct substitution. If it works, you're done. If that doesn't work, then try factoring, like that last example. Direct substitution didn't work. And always try to use a graph or table, especially graphing calculator. You can verify your answers. So, for example, this case right here, okay, direct substitution, but you plug in a negative 3 here, and this all becomes 0. So that doesn't work. So I'm going to have to go back to factoring. So on this top here, x squared plus x minus 6, I know that's going to factor to an x plus 3 times x minus 2. They have to multiply negative 6 and add to positive 1, all over x plus 3. Well, when you do that, what cancels? X plus 3's. So my new limit is x approaches negative 3 of x minus 2. And so when you plug in negative 3, that becomes negative 5 for your answer. All right, let's talk about this indeterminate form. So sometimes when direct substitution, it gives you 0 divided by 0. And that's weird. You can't determine what that is. So for example, if you did it for this one, you plugged in 0, you would get square root of 0 plus 1, so 1 minus 1 over 0, which would be 1 minus 1 over 0, 0 over 0. What do you do? Well, what we can do is we can use something called the rationalizing technique. So you rationalize the numerator, and this is going to be how you do this in this case, because we kind of have two terms up here. We can multiply it by the conjugate. And the conjugate is a binomial, but instead of minus, it's plus. So the conjugate of that numerator is going to be square root of x plus 1 plus 1. And multiply that on the top and bottom. X plus 1 plus 1. So what happens is you have basically the difference of squares here. This is the factored form. And what that's going to come out to on the top is the first term squared, so square root of x plus 1 squared, minus the second term squared, so 1 squared, all over x times square root of x plus 1 plus 1. And this is going to happen, that square root and the squared is going to go away. So we're going to get, and this is going to equal x plus 1, so these go away, cancel each other out. X plus 1 minus 1 over x times square root of x plus 1 plus 1. And if you combine like terms on that top, you're going to get, and I should move this down, obviously we're going to need more room, so it's going to be x over x times the square root of x plus 1 plus 1. And what cancels out here? Those x's. Boom. So all you're left with, and I'll write the work over here, is 1 over square root of x plus 1 plus 1. And we're actually trying to find the limit, remember? So the limit as x goes to 0. So the limit as x goes to 0. That was the whole point. We can just do some direct substitution. So direct substitution says that's 1 over square root of 1 plus 0, or 0 plus 1, so 1 plus 1, which is going to be 1 over 2. And that's your answer. So sometimes that's one way to get an answer. All right, 2 special cases for limits. And this is just ones that you're going to have to know. Especially this first one pops up a few times. So limit as sine of x over x approaches 0 is 1, and the limit of 1 minus cosine of x over x equals 0 as x approaches 1. And I circled those with really special designs. So hopefully you remember even better. All right. So let's do the last example here. So I want to find the limit of tangent of x over x as x approaches 0. And if you try to just plug that in, you get tangent of 0. Oops, let's use normal pen again. Where's normal pen? I don't even know if we have a normal pen. There we go. So this is going to be tangent of 0 over 0, which is 0 over 0, and that doesn't work. So let's break up this tangent. I can rewrite this as the limit as x approaches 0 of tangent sine over cosine. So sine of x over cosine of x, times another x, times a 1 over x. And let's rearrange this and put that x as sine of x over x times 1 over cosine of x. So that limit still as x approaches 0. And we found from the last properties that we already memorized, but I haven't, is that equals 0. This approaches 1. So in this case, we can break these up. Limit as x approaches 0 of sine of x over x times the limit as x approaches 0, 1 over cosine of x. And knowing this, we know this limit right here is 1, times if you're plugging in 0, you get 1 over cosine of 0. Cosine of 0 is 1. So 1 times 1, and so your answer is 1. That's it.